My name is Rónan, and I'm going to talk about how human-led AI can save market research. Brief agenda for today, I'm going to do a quick intro of myself and Bounce, the company that I co-founded. We're going to talk about Bounce's AI engines, focusing on that human-led AI. Then I'm going to talk a bit about what we learned working with AI, and hopefully there's some useful stuff that you guys can take away to your practices, and also what we expect from the future of AI. If there's any questions, just feel free to leave them at the end. I'm comfortable taking questions on Bounce AI, what we've learned, what we expect for the future, anything you have at all. So as I said, my name is Rónan Dowling Cullen. I'm the co-founder and co-CEO of Bounce Insights. And I've always been obsessed with this confluence of human and AI, right? I studied computer science at university, and there I started to learn about machine learning and how humans can work with machine learning to have really, really powerful outcomes. I founded a business at a university, and it failed drastically because we didn't do any consumer research, funnily enough, and that drew me into the market research industry. And here I found a great problem to solve with human-led AI, which is end-to-end insights, right? And that's what I'm talking about when I'm saying saving market research. End-to-end insights are really taking a plain English business problem and turning that into insights that can answer business questions for clients. At Bounce, we are transforming decision-making for leading brands, so focusing on how they can make decisions faster using high-quality data, high-quality research. We work with Diageo, Coca-Cola, Pernod Ricard, and they come to us for agility, speed, and our support, right? But enough about that. Let's get into the meat of it a bit. Bounce AI engines. So, like I mentioned before, the goal here is human-led AI. So how can we take a plain English business problem that anybody in a brand can understand and end up with a business decision as quickly as possible using high-quality market research? And when I say quickly, I mean on the order of hours, right? So it can actually be used in business decision-making rather than 4 weeks, 8 weeks of a normal market research process. We achieve this at Bounce through 4 AI engines that we have. We have a retrieval engine, a survey engine, a data engine, and an insights engine. And I'm going to tell you now a little bit how those work. First, let's look at what a business question is. So a business question is a plain English statement or question that anybody in the brand can understand. Here are some examples of ready-to-drink alcohol beverages and questions you might have about them. So characteristics that are most important to RTD drinkers at home, or how should you promote a new RTD brand? Things like this. They're not market research specific, they're actually brand specific or focused on the client problem that our clients have. What we do is we feed this plain English business question to our retrieval engine first, and this identifies the data that our clients already have that's relevant to answer those business questions. So this could be social media data, point of sale data, anything that's relevant to answer that business question. A really important key here is that the retrieval engine also identifies gaps in that data, because we don't just care about specifically the data that you have available, we also want to know what data do we want to gather to be able to answer that business question fully. The original business question and the gaps identified by the retrieval engine get fed to the survey engine now. And the survey engine generates a high-quality survey in about 5 to 10 minutes to fill in those gaps and answer that business question. This survey then gets passed to the data engine, which automatically gathers responses from real consumers, and then cleans that data as well using AI. And then lastly, the primary data that we've just gathered and the secondary data that I mentioned earlier from our clients gets fed to our insights engine, which pulls out plain English insights that are easy to understand and solve that business problem for the client. If the client has any additional questions, they can ask questions of our AI chatbot in the same way that they would interact with a research consultant, right? Here you can see they've asked the chatbot about promoting a new brand to drive trial, and the AI chatbot suggests bars and outdoor events could be good places to promote it. What we're really going for here is allowing researchers within our clients or the organizations that we work with to interact with the AI in the same way that they would a research consultancy, right? So instead of being dependent upon a team of other human beings that exist elsewhere, they're able to do all of the heavy lifting themselves using the AI, and that speeds up that turnaround time on every step of the process. That means you can get from that plain English business problem through to a decision in 3 or 4 hours rather than the 4 to 8 weeks. And like Frank mentioned earlier, a lot of these companies are moving away from market research, or they're not using market research as much, and it's because they can't actually answer the business questions that they have in the time needed to be able to make decisions, right? If it takes 4 weeks to figure out using market research how you should go about a new trial or a new product you want to launch, but your competitors are launching in a week, you need to either make a gut feel decision or use some other data that you have, some other statistical analysis or things like that. So we're focusing on how can we bring market research and primary market research specifically back into the fold in that decision-making process. The next step from all of this is prediction. So the ultimate goal of market research is not to understand the past, but actually to predict the future. And there's a few things we're working on here that I'll keep maybe to questions at the end or to any discussions anybody wants to have. But ultimately, we're focused on pulling out predictive and correlative relationships, similar to what Frank was talking about earlier, to be able to predict future performance of campaigns. I'm going to move on now to what we've learned from building this AI, and specifically large language model AI or generative AI, as Frank mentioned earlier. So the key to working with large language models is thinking like a human, and this means thinking like a human in how you design and train and build your AI, so treating it like you would any human being, right? You don't just chuck a load of data at an AI or at a human and go and solve the problem for me. You give them a bit of context, you might break the problem up into smaller chunks, you might teach them how to do different parts of that, and that's really important here. The other side of it is actually understanding the user, right? So the end use case. And the key thing that we found is latency is incredibly important to end users. So end users being clients of ours or clients of yours or organizations you're working with, if latency is super high, they won't use a platform. And what I mean by latency is the response time when you ask a question of a generative AI piece of technology. So if you pose a question to a piece of generative AI or a tool that you're using and it takes 15 seconds to come back with an answer to you, users will just stop using that. They drop off really, really quickly. And if you imagine you were sitting beside a colleague of yours and every time you asked them a question, even if it was super simple, it took them 15 seconds to reply, you'd get frustrated pretty quickly. You'd say, "Feck this," and you're going to go and work on your own or do other things yourself. So a real key to getting usability and actually adoption of our product or of your product is going to be reducing that latency. The next piece, and this is going to be important later as well when I talk about the future of AI, is interoperability, right? So I talk about interoperability of GPT providers here, but also large language models, which are somewhat interchangeable worlds. The reason why I say this is if you hitch your wagon to one particular LLM, so let's say GPT from OpenAI or Mistral being an open source one, or Llama 2 or Llama 3, which is Meta's one, you can end up in a situation where you're behind the times, right? These large language models are adapting and evolving so quickly that if you stick with one type, you're going to end up in a situation where a competitor of yours or a client of yours or somebody is much further ahead because they've been able to adapt and move with the large language models that are coming out. So interoperability is a key here because it allows you to hot swap those models. That's one thing we've really focused on. We're constantly testing the latest models, fine-tuning them on our data, training them in a way where we can use them at any stage of the process that we use large language models, and that enables us to stay with the curve. And I'd suggest that you guys do the same thing. And then the last point here is around hallucination. So hallucination was a huge issue when large language models came out, and I'm sure you've all seen the memes of sending images of ChatGPT saying 2 + 2 = 4, or the sky is purple, or things like that. And that's because these models are based on prediction, right? So they're probabilistic. They're trying to predict what the next 3 or 4 words are. And they have a vector space in their head, right, where they match words together and say, okay, these 2 words are similar in this context or not similar in this context. And that's why purple and blue, they're similar colors. You can see how a model might think that they're similar enough to try saying, okay, the sky is purple this time. What we found is as these models evolve and adapt, hallucinations become much, much less common. And particularly for really easily identifiable hallucinations, they become much less common as well. So that's good in some ways because it means that there's less mistakes from these models, but it's also a little bit concerning because the mistakes that it does make become harder and harder to spot. So building protection around that is super important. Lastly, I'm going to talk a bit about what I expect from the future of AI, or what we expect. And there's a couple of key things here. We expect it to be fast, adaptable, and scalable. Inference speed is increasing drastically, and this is going to be incredibly important for the number of applications that are coming out. For anybody who doesn't know, inference is the use of AI, and there's kind of 2 types of work that goes into building an AI model. There's training, where you feed it all the data, you teach it some context, and you let it churn away, right? OpenAI's ChatGPT is trained on the whole corpus of data on the internet, and you give it all that data, you let it churn for ages, you use loads of compute to get it to a point where it works, and then inference is like asking a question of ChatGPT, right? And that inference actually is tied really, really closely to latency, right? So that inference speed, the inference being done by ChatGPT impacts how quickly it's able to respond to questions, right? And as inference speed increases, your latency comes down, and that means that more products are possible, right? So not just products that require one turn or one request response from a large language model, but if you imagine a lot of companies are streaming together multiple responses and ending up with really, really high quality output, but it takes 5 turns going to the AI, right, each time. And if your latency is super long or your inference speed is slow on that, you can end up with 1 minute, 2 minute turnaround times to perfectly solve a problem, but like we talked about earlier, nobody's going to use it. So as that inference speed increases, we're going to see a drastic increase in the number of applications because more applications are going to actually be usable to clients because the inference speed is lower, the latency is lower, and it means that they can actually be used properly. The next point ties to the interoperability I mentioned earlier. So open source models are going to become good enough, right? Right now, for us, GPT is best in class for most of the stuff that we do, but we've looked at Llama, we've looked at Mistral, we've looked at Gemini, and we looked at Grok actually a little bit as well. And these models seem to be between 3 and 6 months behind the leader at any point in time. And if you think about that in the evolution of businesses, right, 3 months is almost no time at all. So if you're willing to wait 3 months, you can get an open source version of a model that's probably cheaper, more stable, and you don't have to rely on some large tech overlords to use your technology. And I would say the interoperability is super important here because it means that you can drop a proprietary model for an open source model when it becomes available, when it becomes good enough. Another reason why open source models are super important is because of the weights, right? So you might have heard the weights mentioned, and I'm sure a bunch of you guys are computer scientists in here, so you'll know all about it, right? But with private models, the weights are private and they're variable, so they can change over time. And that means that if you're building on top of large language models, the ground can move under your feet a little bit, right? Sam Altman tweeted like a month or two ago, and he was like, oh, ChatGPT has been a bit slow lately. I've changed something and now it's going to be great. And I was like, hang on a minute, like, did you release a new version? Where's the documentation for this? What's going on? And basically he changed the weights, or his team had changed the weights behind the scenes. And that can mean that your application that you've built on top of a large language model can break very, very quickly and very easily because most of us are going to be working for smaller organizations that don't have deep relationships with Sam Altman or OpenAI, and if our use case breaks, they don't really care. So an open source model means that you can control the weights, you can set the weights, and it means that the ground doesn't move under your feet. If you are using a closed source model as well, just FYI, I would suggest that you protect against this through unit testing or end-to-end testing, basically automated testing to ensure that the weights haven't changed in a way that's going to break how your application works. So we do this on a kind of every 10-minute basis. It's a little bit expensive, but we're a bit paranoid about OpenAI. The next piece is models operating on large, raw, structured data sets. So right now, models are pretty poor at retrieval augmented generation, or basically using a large data set that you feed it, right, in inference, to give you back, interesting insights or key takeaways from a large data set, because they're really bad at doing 2 steps or 3 steps at a time, right? So they're not able to take a data set and then build a contextual model of, oh, here's all the important parts of the data, a lot of the interesting stuff that Frank does, and then do inference on top of that. But this is going to change, right? And we're starting to see this with GPT-4o, so 4Omni, which is the latest model from ChatGPT. It's able to handle much more data. It's also able to infer structure from that data, and this is going to get better and better over time. And that means that soon models will be able to take an entire survey data set, pull out a structural model around that data, so metadata around that data, and then infer insights to solve business problems or organizational problems. And that's very exciting. It's very scary as well for companies like us or people who work in the market research industry, because there's going to be a huge rise in analysis tools, effectively, that can solve business questions for clients. And then the last point is access to models is going to be very cheap. So like I mentioned, there's open source models coming out, and a lot of these large language models are converging towards the same outcome, right? So they're all achieving a similar thing. It's effectively text prediction using some context under the hood, and they're all going to get to the point where there isn't new additional data that you can feed to them that's going to make them better as generalist large language models. So when you have multiple competitors who are all converging towards the same point, you end up in a commoditized market, and that means that these models become cheaper and cheaper over time. And actually what's interesting is the applications you can build on top of them. But like I mentioned before, if things become cheaper and things become faster, you end up with a higher number of applications. So we're going to see a significant increase in applications coming out that weren't previously possible to be profitable, right? It costs too much to use OpenAI servers to run your product, but as they get price competitive and those prices come down, they're going to have to they're going to be able to build more products. People are going to be able to build more products. So just to finish, right? When I'm talking about human-led AI and it's saving market research, really what I'm focusing on here is allowing businesses and our clients and your clients to solve business problems using market research at the speed of business decision-making, and you can achieve that through AI. And then when you're working with AI, focus on being human-led, so human-led in how you understand how your clients are going to work, but also human-led in how you train your AI and teach your AI to solve problems. If you can, build interoperability into what you're doing, because the ground can move under your feet. If a model changes, you need to be able to hotspot it out, and then also be conscious of a lot of analysis tools coming out over the next 6 months, 18 months. That was me. Any questions?
Thank you.
Your hand first, or sorry, you could take the mic.
I wonder if you could give us any advice on pricing services to clients. So it's the unpredictable, as I see it, it's the unpredictable workload which you might provide to your client, and so if you're trying to price some work or price a service, you don't actually know what they're going to put in and how many tokens they're going to be using and so forth. I'm just wondering how a small business might do that.
Yeah, for sure. So we spend a lot of time thinking about and working on pricing, because we're an early stage company like you guys, right? Pricing is incredibly important to us continuing to exist as a small business. But it's also very variable. So what we're providing to customers is changing all the time, and what customers are looking for from us is changing all the time. I mean, one easy solution, I'll knock this out of the way first, is just bake in so much margin that it doesn't matter anyway, but I assume that's not a solution for you. What we've done quite well is consumption-based pricing. So we have subscriptions with our customers where effectively a retainer where they get some amount of consumption, and that consumption can be data, right? So it could be getting survey responses, it could be buying secondary data, but we also have a consumption piece on the AI. So the way that the pricing model works behind the scenes with large language models and most AI models and most hosting and like AWS, Google, these types of things, is they have a credit system, and the amount of credits you use is then correlated to some cost. We do a similar thing internally. So when a client is looking for something significantly large dealing with data, we do a consumption basis on that, and we go, okay, you can have 200,000 credits or 2 million credits or whatever that is, and then they're able to use that on their data as they go, and then we bake in really nice ways for us to top up that subscription and all that good stuff as well. But generally speaking, if you can bake in a shitload of margin, that'd be great, but if you can't, focus on some sort of retainer and then a subscription or a consumption-based model, both on data and then on the AI usage.
Have you explored them providing their own AI key?
We haven't, usually because our clients wouldn't be as tech savvy as maybe yours might be. So we're primarily focused on blue chip FMCG brands. So we'd be working with the market research team within Coca-Cola, let's say. So they might have access to some AI stuff, but they prefer if we handle all of that. We have talked to a few large tech companies. So we do a bit of stuff with consumer focused tech. And we've talked to them about it, but we haven't done any of it in real terms. If I was doing that, I would be trying to bake some margin into it for yourself, just because there's going to be overhead and costs to you guys in dealing with managing that process. But I would actually probably still tie it to consumption then, but they still pay for the credits, because you can map your overhead to the consumption they're using.
One question here. Yeah.
I'm Bernard from Survey Tester. You mentioned the open source models. How does that work? Do you install that on your own servers, on your own machines, or is that still somewhere in the internet hosted by somebody?
So it varies from model to model, and it varies from provider to provider. So you can take an open source model and you can take all of the code and you can take all of the weights and you can run it on your laptop. Some of them are small enough to run on like a MacBook Air, right? And generally speaking, if you want to run stuff at scale, I would suggest that you use a provider. So look for a third-party provider that would host a model for you. And there's going to be more and more of these coming out as these models come through. We haven't used any internally ourselves because we have our own servers, so we host it on our own proprietary servers. But if I was trying to do stuff at scale, we will end up using a third-party service that's going to host Mistral for us, right? Hugging Face is a great like repository for all this sort of stuff. So if you check out their site, I'm sure that they have, oh, here's a way that you can host Mistral's model and just plug in the weights or use the default weights and it'll be up and running, and then you get charged by AWS and some provider who's taking a bit of margin there.
Okay.
No worries.
Thanks, Ronan. Yeah, my question, you're not going to be surprised by it, is like, I want to understand more about prompt crafting, how, especially because you've got different agents. You've got an agent that generates a survey, another one that tests it, another one that makes sure it follows methodology. I mean, I'm not exactly sure about how your architecture works, but so how do you create prompts for all of them? Is it, do you review that and do you adjust temperature? Like a geeky question.
Yeah, for sure. So prompt engineering is super interesting because it's really hard to measure performance, like actual performance or a prediction of performance of a prompt, because generally speaking, in our sort of work, you're not just writing one prompt where it's like, oh, asking a question about the weather. It's like, ask a question about this data set that I'm going to plug in. So the prompt is actually variable, right? So you're trying to figure out a way to take a prompt that has variable data plugged into it and then has non-deterministic output, to be able to measure the performance of that. So what we do is we have kind of a standard bank of test cases or test questions that can be asked after the fact. So we take a prompt and we plug in 100 different variations of the data we expect to be in there, and we feed that into our multi-agent architecture, and then we measure the quality of the output, and we get a percentage score. So that's how our process works of finding the best prompts for each step of the process. You need to do some sort of statistical sampling, effectively, of how these prompts are going to perform in real-world type scenarios. Or this is very abstract, so I'm going to make it a bit more concrete. Let's say you've got a prompt that takes the data for one question crossed out by another question in a survey, right? And you want to pull out what are the statistically significant or like the most interesting and relevant pieces to the business question. We would feed that in for 100 different questions from different surveys, and then we would measure the quality of the output. So take all of the outputs, and you can feed it through AI that you've trained to measure performance of these, but also you can use humans as well. So one thing that we've done a lot of is we take the output as a first instance, and we run it through a statistically relevant sample of market researchers. And we go, how good is the output from each of these prompts? And then we're able to get a score for each of the prompts that we put in originally. Did that answer your question?
Yeah. The problem is like it's a moving goalpost. You need to re-engineer your prompts all the time. I imagine, just to get the better outcome, and then the LLM changes as well. So do you sometimes have surprises or
Yeah, so that's kind of what I was talking about earlier with the weights, right? So when you're using closed source models, the weights can change, which basically means for the same prompt with the same data, you can end up with a different outcome. Now that's true always with non-deterministic AI, but the weights changing means it can change significantly. What we do is we have automated testing that runs every day on, like I was saying, a bank of prompts. Through the model or through our different variations of the model, and ensuring that the output is still broadly in the same range of quality, right? So there's going to be some variance in there because it's non-deterministic, and it's going to be a little bit better today, a little bit worse tomorrow, but like we're talking 97% to 93%, that sort of variance. And then if at any point our tests come back and go, actually it's 80% today, then we're able to pull plug, we're able to figure out, okay, what's actually going on, and then we're working on having actually a base case of our technology that works on open source models where we control the weights, so we have it guaranteed, okay, 90% guaranteed all the time. If something breaks, something goes wrong, we just hotspot into the open source one, but the closed source ones are better and more performant, so we use them for now.
Any other questions, maybe? There, yes.
You mentioned the credit-based model for your clients. Is that linked to the sample usage, and where does your sample actually come from?
Yeah, so the credit-based model has two sides to it. So there's data and then there's AI usage, right? But on the data side, yes, it's linked to our sample. We have two broad inputs to our sample. We have a mobile app with like around 10,000 people on it in Ireland. It's the biggest and best sample in Ireland, which isn't that impressive because it's a very small country and you don't need that big of a sample. But what we figured out was we built a load of technology. We actually built some AI around engaging consumers, and we got completion rates up to 80%. And we were like, happy days, we're going to the moon, this is it. And then nobody really cared because Scint and Lucid and Pure Spectrum exist. So we just started using them as well. So we use third-party panel providers as well for outside of Ireland. So we have some relationships with some in particular, but we also use our clients' preferred parties as well. It doesn't really make a difference to us.
How are clients kind of reacting to using this level of AI? Is there a nervousness there? Like, how do you account for that? Or are people perfectly comfortable using this?
Yeah, so I'm not usually on the sales side of things, and that's usually where these concerns would come up. What we found is people are really, really happy with it, particularly on the insight side of it, right? So there's kind of 4 steps to our process. There's retrieve existing data, there's design a survey, there's gather data, and then there's analyze all that data. The analysis, they're like happy days. They're all about it, absolutely love it. The survey side of things, some people still feel like they can write a better survey, and some people still have like surveys that they've designed or templates or processes that they want to use internally, so we've had less adoption there. I'd say the biggest concern that ever gets raised is worry about cross-contamination of data. So we work with companies that compete with each other, and they're sometimes concerned that, if they're writing a survey, if Coke has a new type of Coke that's coming out, right? Is it possible to reverse hack your way into our models so that Pepsi could go in and try and figure out what Coke's already done? And we just build a really good protection around that. So if clients want it, we can completely segment their data and just have a model trained on only their data and nobody else's. But what we do for all of these anyway is we just remove the keywords and key name factors, so you actually wouldn't be able to tell anyway. Did that answer the question? I know there's a lot in data concerns and stuff.
Well then, thank you very much.